This project proposes Direction-Based Authentication, or DBA, a novel selection-based authentication method that is both memorable and efficient to use without compromising its security. There are two main types of selection-based authentication in virtual reality. The first type is text or digit-based authentication. The characters or digits are typically aggregated on a single panel, allowing for efficient entry. The other type is context-based authentication, which provides a context to users and achieves good memorability. But this type of authentication usually requires longer entry time. DBA combines both in a seamless manner via the snap turning technique, in an attempt to achieve the best of both worlds. The password of our DBA system is a sequence of 4 directions in 4 different environments. In each environment, there is a compass floating in front of the user, which divides the world into 8 directions. The user can select and enter any direction as a symbol of the password, and remember it by either the text or the context corresponding to the direction. This virtual reality experience is implemented in Unreal Engine 5 and is compatible with the OpenXR standard. The demonstration is recorded on a workstation with an NVIDIA GeForce RTX 3080 Ti graphics card. In each environment, the initial direction of the user is randomized to protect the password entry against observational attack. This is the first environment and we have not entered anything yet. Therefore, all 4 directions of the passwords are shown as blanks. The user can tap on the direction button on the compass to be snap-turned towards that direction. The user can also physically rotate their head, which makes it more flexible and convenient to get familiar with the environment during the password creation phase. A frame will show up when the user changes their view direction to highlight the corresponding context, which helps the user memorize the accurate visual information. The hand of the compass is always pointing to the view direction. Pressing the Enter button will record the current view direction and load the next environment. The user is now in the second environment. The direction entered in the previous environment is recorded and displayed. The user can tap on the backspace button to go back to the previous environment and re-enter the last direction of the password. As mentioned earlier, besides memorizing the text of the direction, the user can also memorize the context of the environment, such as the red car in the southeast direction or the gazebo in the southwest direction. Therefore, we selected environments with different visual features in different directions, which is also recommended for customizations on a per application basis. After the user enters all 4 directions, the Enter button will turn into a Confirm button. The user can then press the Confirm button for authentication, or they can press the Backspace button to modify the password. In our internal test among the 2 developers, the mean time of the authentication was 8.48 seconds when all 4 directions were entered via snap turning, and 9.21 seconds when all were entered via physical turning. The DBA system combines the text-based and the context-based authentication methods to facilitate memorization and allows both physical turning and panel-controlled snap turning to enhance memorability without compromising efficiency. It provides a more balanced authentication method compared to authentication methods based on either text or context only. Furthermore, randomization is introduced to ensure the security of our method against observational attacks. For future work, a formal study is required to more thoroughly evaluate the efficiency, memorability, and security of the method. The authors would like to thank 51HDR for supporting the project with HDRI images.